Good morning, everybody, and thank you very much for joining this working group for optimizing power grids. This is going to be a wonderful discussion that we have prepared for you on aligning incentive regulation with public interest. This is a topic that has attracted a great deal of attention, so very much looking forward to hearing the comments from our speakers. It's been in the last 12 months where we've seen great acceleration of this discussion on the role of incentives to drive the behaviors and the market dynamics that I think many of us agree are needed to deliver greater efficiency and optimization of the power grid. And what's interesting to me is that these discussions are happening all over the world. So given the fact that this type of conversation, these very things are reaching what I think is a tipping point, and what we're seeing is the process of now deciding how to implement, not just whether we should implement. And I think you'll find that our panelists agree on the broader themes, but how we actually implement that is really what we're here to discuss today. Now I will turn it over to Suzanne to introduce Current and Marcus. Suzanne.
I'm on the one hand the board chair of Current. We are new kids on the block, can still claim that, 1-year-old association representing grid enhancing technology stretching from superconductors to various types of dynamic line rating to the FACTS devices, working on TSOs and DSOs, collaborating with Digital Grid Initiative, and sitting in the NSOE Technopedia group, as well as on the Infrastructure Forum, Florence Forum. So we have our say and are appreciating to exchange with you. So why are we doing this all together, this event? This is clearly because climate change is a reality today. You see on the right side, that's the future of the global future, these kids that rightly claim to keep the planet in good shape. That's our responsibility. And this means electrification, 60% probably or more by 2050. Big challenges. And we know that electricity can hardly be stored, and therefore networks are central. Those networks are expensive. We talk in Europe about 500 billion to be invested by 2030. In Germany alone, it's 84 to 100 billion euro to be invested on only high voltage transmission. And we need to make the best out of those long-term investments, 40 years plus, and therefore grid enhancing technologies that go against those high costs on congestion or curtailment are absolutely needed. Our technologies are on the shelf and we want them to be used now. It's not the case because, for example, the capex heaviness of the regulation, because, for example, a certain delay in using new things is a given. That's why we claim use those technologies now, and we are very keen to hear all of your perspective on how we can progress and act together.
Allow me to welcome everyone who is connected for the discussion of today. And thank you also for this introduction and for inviting me to participate to the debate of today. When I was looking at the topic of the discussion of today, it's quite large. What means as well that there is a necessity, of course, to align and to find an alignment between quite a lot of different stakeholders to implement things and to make them fly. In Europe, if we want to reach the carbon neutrality in 2050, when I'm looking at the Green Deal, for example, and the translation of the Green Deal over the years, all of you knows that we need already by 2030 to reduce our greenhouse gas emission at least by 55%. Or saying it differently, we will need to do in the next 9 years what we did in fact the last 30 years. And let's be honest, if we don't reach this goal by reducing this gas emission by 55% in 2030, it will be very difficult to reach this carbon neutrality in 2050. So 2030 is, in my opinion, a very important milestone. That being said, which are the main challenges or hurdles that we have to overcome, but also what kind of solution are possible? First of all, I think we need to think in a more open and inclusive way. It's for me not or nuclear or gas or wind, or sun, or hydrogen. It's and. Therefore, I believe also in this decade, we must first make use of all mature technologies to reduce and smartly use energy while making it cost efficient, for instance, through building renovation. So a lot of people are aware that important grid investment are needed to enable this rapid decarbonization. And together with more classical solution, we will need to be successful, to find also novel solutions. Don't forget, on the other hand, that the system, and I'm talking about the electricity system on its turn, will be put more and more under stress. So it's not just a question of investment in the system, but it's also guaranteed the good functioning of the system. And this brings me, in fact, to the importance of a well-calibrated regulation allowing shareholders to satisfy the expectation on return on investment, and also the importance of right, and I'm really emphasizing on that, the right incentives to be sure to deliver an adequate future power system. And because this transition will involve really huge investment, and at the end, if we are really honest, it's always the consumer who will pay the bill. I believe it's almost of utmost importance to make everything very cost efficient. So this regulation and this incentive system should support not only cost efficiency, but also what I will call the risk taking and innovation, and enable system operator to use innovative solutions, and these to deliver the social gain on a shorter term. Again, an example for that. In the winter 2014-2015, we experienced here in Belgium a very tough situation from an adequacy level for the winter, and we saw that. So we were searching for solution, and we find one part of the solution in a new technology for us. New technology, I mean, with that, not really implemented at large scale in our network, namely the dynamic line rating. And by installing this kind of equipment on very important line, know that we increased, in fact, for the winter, the import capacity of Belgium during the winter by, on average, 20-25%, helping us to go through the winter without any additional problems. And honestly, after this winter, we saw also very quickly and in a reactive way, our regulator, how will I say, really highly facilitating the further process to implement this kind of technology further in the network.
So Rina, I will turn it over to you.
Thank you. First of all, we see the same things as the previous speakers in terms of the industry trends. There's relatively new requirement to release this 70% of cross-border capacity for day-ahead and intraday power exchange. This is an important regulatory piece for us. This regulation, as a result, is anticipated to cause congestions, not only on cross-border components, but inside a country as well. And there's also ambitious targets to integrate more and more renewables quickly, over 500 gigawatts more than today by 2030. And this indicates that grids will only be more congested despite the reinforcement and the build-out plans, and the costs to get rid of these congestions will remain high. And on top of this, there is the NIMBY, right, the not in my backyard problem, which delays the realization of these major build-out plans. And there will be not only rising congestions, but also rising pressure to reduce the congestion management costs as well. That's what we expect. We need to be on top of all of this, to achieve the carbon neutrality goals by 2050. So we see plenty of reasons for the deployment of grid enhancing technologies like the ones listed here, dynamic line rating, power flow control devices, superconducting transmission, and intelligent sensors that give more visibility. But as technology providers, we feel that the uptake of these solutions could be faster, and society would also benefit from a much faster deployment of the technologies. So our question is, what is preventing this fast uptake, and how can we speed it up? As members of Current, as I said, we're no experts on regulation, but we have some humble observations that in different regulatory regimes that we have observed, it spurs relatively fast adoption of technologies, and that's what we list here. I'd like to share some of them. First, we consider Belgium to be a great example. That's why we have Mr. Marcus Berger here as a keynote speaker as well. They have experienced this fast and wide-scale adoption of dynamic line rating and power flow control devices, and this was spurred on by output-based incentives by the regulator. A portion of the value generated by the increase of the import and export capacity can be claimed by the TSO, and this has become a huge trigger for speed of adoption. And so this is one of the main reasons probably why also now in European Union, the regulation demands 70% cross-border capacity to be available for the market trade, because this kind of incentive then for increasing the cross-border exchange, power exchange, this will deliver market efficiency gains. And if you can capitalize from that, then it's benefit for everybody. In Germany, we've seen just this year some changes. It was mentioned by Suzanne at the beginning. Finally, we introduced an incentive instrument to reduce congestion management costs of TSOs. Also, Redispatch 2.0 is taking effect as of next month, and we have very high expectations there that further steps will come in Germany. In the Netherlands and Belgium, the NIMBY, the not in my backyard sentiment, is quite strong. And this means that the governments have put in legal restrictions on the type of new grid build out. And this has acted as a strong disincentive for investment for expensive CapEx projects, right? And it's acted as an incentive to look for alternative solutions that are cheaper than underground cables to deliver the needed grid capacity. And in France here, the new wind farm connections cannot be refused. Sorry, it's not the curtailment penalty, but there's a penalty that applies for not connecting the wind farms if they have applied for connection. So broadly speaking, we see both the carrot type incentive on the left side and the stick type incentives on the right side as both being very effective in getting TSOs to move. And our conclusion, is that both types work. Regulation is good. What we see as most effective is regulation that aligns the TSO behavior with public interest, and where parts of the benefit is shared between the TSO and society. And so generating social welfare alone is not really acting as a motivation for TSOs to move, but the business case has to be clear for the TSOs. How will they gain return on their investment in these grid enhancing technologies? And the lack of the clear monetization pathway makes it challenging for them to establish a credible CBA. So this can be seen as a bit of a blocking point that could be helpful with more clear regulation. So yeah, we think that more explicit rules on this will help TSOs assess their business case and will spur faster adoption.
Thank you very much for the invitation. Today I will be focusing on Italy. Let me start from the pilot projects, and I go back to 2012. So the regulator introduced a pilot project for TSO-owned storage and included a minimum requirement that dynamic line rating application should have been included and tested and publicly disseminated. The details of the regulatory scheme, it was an increase of the weighted average cost of capital, meaning an increase of the return for the cost of the storage and DLR technology. It was conditional to some actual outputs in terms of reducing the curtailments of renewables. There were different tests, and some of them achieved the target, some not. But the interesting result, rather than the, let's say, the rewards for the TSO, is the impact at societal level. The cost of investment for the dynamic rating was below 1 million euro, and the actual benefit after 1 year were already the double. And by the way, this is the double valued at the price which, well, today is quite different across Europe because it was at the time valued at 40 euro per megawatt hour, while current prices are much higher. So that was our the main result of our experience with the pilot projects on dynamic line rating, but it took till 2017, small, in the line at the bottom, there is a date, which is 2017, which was the time needed for the regulator to put in place the framework for the TSO to embrace the challenge, to put in place the projects, to run the projects. So it always takes time to go with new technologies. Since 2015, the Italian regulator started introducing additional, meaning additional to the historical, let's call it, regulation promoting quality of supply and reliability of supply. And this output-based investment intend to promote all investments under a technology-neutral approach according to their expected benefits. The concept is, in the end, to give a small part of the benefit of network investments to the TSO, leaving the majority of the benefit to all other network users. The possibility to account for benefits, and here there is a list from Italy. It's actually not complete, but it's most of the benefits we are considering: increase of socioeconomic welfare, integration of renewables, reduction of greenhouse gas emission and reduction of non-greenhouse gas emissions, reduction of energy not supplied, reduction of costs for dispatching and balancing services, and reduction of costs for mass run units. This second message is focusing on the value for the entire society, the value from networks. But apart from technicalities of the regulatory framework, which is, well, as a regulator, sometimes we fall a bit in love with those. But the important thing is to look at the actual implementation. And currently, we are looking at the first preliminary impacts. The TSO published the indication that for internal cross-zonal capacity across Italy were improved by January, since January early this year, January 2021, by using a combination of means, which includes dynamic line rating, special protection schemes, and other low CapEx intensity network measures.
Yes, good morning and welcome to the webinar also from my side. My name is Michael Berger and I'm co-leading the ESA Infrastructure Efficiency Expert Group together with Jan Kosteus from ESA. Firstly, I would like to start with the CR paper that was developed last year, triggered at the Copenhagen Infrastructure Forum 2019 as a result of the EC Commissioned ECORIS study on the support of innovation and security of supply in European electricity and gas infrastructure. The ECORIS study recommended a series of regulatory measures to be implemented by individual NRAs. CR conducted a questionnaire to assess the status of this implementation of the recommended measures. The findings showed that some measures were already included, while others were not easy to be implemented, were currently assessed, or were planned to be implemented in upcoming regulatory updates. Another finding of the questionnaire was that most NRAs share a common understanding that innovation is correlated with development that increase grid efficiency and benefits for network users at the same or even lower cost. In addition, specific actions for innovation have been or are being adopted in several countries. The Electricity Directive also defines the duty for regulators to assess and monitor the performance of TSOs and TSOs in relation to smart grids that promote energy efficiency and the integration of renewables in a limited set of indicators. Additionally, an improved CBA methodology could highlight the benefits and the potential faster implementation of innovative solutions compared to traditional investments.
Today, I'll be presenting some of the key messages from the position paper from ENTSO-E that was published in April of this year, highlighting the need for remuneration frameworks for TSOs to evolve. I would highlight 4 key solutions that we mentioned in our paper. First, we would like to see a clear regulatory framework based on meaningful and carefully designed incentives. And in our paper, we highlight several incentive design criteria, which we see are key for ongoing and upcoming discussions, which will be needed for updating TSO's regulatory frameworks. Secondly, TSOs see a need for lower bounds, or a floor, if you will, of risk-free weights, which determine either the WACC or return on equity of TSOs. And these are needed to limit the lowering remuneration, which we've observed over the last decades, and which will otherwise jeopardize the ability of TSOs to build up equity and carry out the necessary investments needed. The third solution is the need to move towards a TOTEX approach. To put it simply, all costs are regarded as total expenditure, and therefore, based on this, a fixed share of these costs is added to the regulatory asset base, such that it ensures that a bias towards CapEx-heavy investments is minimized, and all costs thereby are treated the same. And finally, the fourth and last solution I would like to highlight today is particularly with regards to encouraging more risk-taking behavior on behalf of TSOs in innovative projects, but also in R&D projects. We believe WACC adders for certain well-defined and very high priority projects will definitely drive future investments in these solutions, be it DLR, FACTS, HVDC, in which already many TSOs are involved today.
I wanted to present another point that is not often brought to the surface when we talk about grid investments, and how much they impact how big impact they can have in enabling investments in renewable generation assets. So the market value of variable renewables is also variable, and it heavily depends on the grid capacity and on the right grid capacity and how efficient it is. So in this graph, you can see that the market value of wind after 2007 was declined very quickly, and a major factor was the increasing curtailment. While after around 2011, this trend was completely reversed, and the major reason was the introduction of new transmission lines. So for the wind sector, ensuring that the grid assets will be as more optimized as possible is important for two reasons. First, to ensure that the renewables will be able to connect, that the assets will be there so that we can connect, but also to make sure that investments in renewable assets will be bankable in the long term. For these reasons, 2 years ago, we started a new work stream at Wind Europe, our task force on grid optimization. It was a group of experts from our members representing the whole wind supply chain, so wind turbine manufacturers, wind farm developers and operators, and of course, grid technology providers. And we, as a first step, we created a library of what we call as grid optimization technologies. We came up with 5 categories, the one you can see on the slide here. We engaged with 5 TSOs leading in terms of innovation projects. Elia was one of them, for example, and we discussed with them deployment projects they have deployed of these grid optimization technologies, the benefits they saw from this, and what they see as major barriers to their wide deployment today. Based on this exchange that has been very, very useful, we developed a position paper, a white paper, Wind Europe white paper, where we developed some recommendations on how we believe that the regulatory framework for TSO investments should change to enable a wide deployment of these technologies. I will maybe focus on the first one because most important first step for us. So we believe that an adequate remuneration framework for TSO investments should remunerate these investments for the total expenditure efficiency and not separately for their capital value and their operational expenditure efficiency. So one system view also from the finance perspective project. And we see as one way to do this, we think that the CBA analysis methodology should be revisited, and we should try to factor in these criteria that are not today factored. And so it's paper like sustainability, efficient contribution to decarbonization targets. For physical assets, maybe the risk of non-delivery of time, or for innovative solutions, the risk of non-delivery of expected benefits, or contribution to the lifespan of assets. Grid optimization projects can also be asset-based ones, not capital-intensive as traditional transmission lines, but they may even increase operational expenses, but contribute to other very important factors like the one I mentioned now. And for example, the recommendation in ENSO's paper to enlarge the regulatory asset base could be a very good start for revisiting this CBA analysis methods. Another point that I don't have here on the slide is that, of course, updating the regulatory framework will be resourceful. It will take time, it will require human resources. So we think to justify this at a European level, a very good driver would be to deploy some studies, wide area studies, European level, regional level, to quantify the benefits of deploying grid optimization technologies. I know there are some national examples today, but I think this would be a very good driver for now.
When you're looking back as from the 2000, and you're looking where we are now, honestly, the liberalization, opening the market mechanism, all the spots on energy that you have in Europe, the TSOs were behind all these new kind of initiatives. So I think we are trying quite a lot. Could we do it better? For sure. But if everyone was looking in the same direction and trying to do his best, then I believe that we could reach these very ambitious goals that were put forward by Europe. Let me say that at ERIA, but I think I can speak in the name of all the TSOs in Europe, we are really open to engage in a constructive dialogue with regulator, decision makers, stakeholders at general, in order to develop the next evolution in the regulatory framework, and this for different time horizon, as I said, short term, but also long term. That will allow us at the end to deliver the future system and grid to benefit society and consumer. So thank you.